we were left with the example of a crane and the way how to treat load cycles, because in old days there was not so much computer power available that you could do for, like you do, for example, for windmills now, that you have 10 minutes of a certain scenario here, then 10 minutes of another one there, and then you in these 10 minutes you count every uh, load variation. um, and the example with cranes is easy because the cranes, they do have some fatigue um, uh, cycles, but they are easy recognizable. So although they use the same Palmgren-Miner curve, which is based on the number of load cycles, stress concentrations, weld quality, and the lifetime, the number of load cycles is transferred in a certain way. Um, because if I have a crane, cranes have one big advantage over other structures, and that load cycle is easy recognizable. What is a load cycle? I pick something up, I move it there, and I unload it there, and that is the load cycle. Yeah, and since these load cycles are so easy to count, they came up with a method for classification. It is this unfortunately I didn't change this. It is in Dutch, but the idea is the same. Here you have the usage class, and that depends on the number of load cycles. And so this is up to 200,000 load cycles. Then you have in the lowest usage class, and the maximum one is more than 2 million cycles. And then you have B and C in between. And here's the description. What does it mean? This is continuous usage, um, and always working. This is continuous working and on a frequent basis. And this class B is description is um, uh, uh, very used on a regular basis, but not in a continuous manner. And this one is use not in a regular base, and there might be big pauses in between. Yeah, so there is, even if you do not know exactly the numbers, you could use the description to come up with a class. That's the idea. So that is the number, the usage. Then you have something else. If I lift something, if so, I don't know, I lift a container, for example, or I have a grab, so some kind of a scissor grab. Drawing is not that good, I think. And then I have here ropes. So if I lift a grab, then the weight of what I lift is always the same, because it's the maximum load. Yeah. So the situation where with a grab is that every grab is full, so the load per load cycle is always the maximum load. While for containers, that's different, because containers you have in different weights. You have empty containers, full containers, and there's also full containers and then maximum load. The maximum load of a container is around 35 tons, but the average weight is only 14. Yeah, and an empty one is around 3. Just ballparks numbers. So if you want to take into account, there should be a difference between always a load cycle, which is always the maximum load, and a load cycle where the average weight is so much lower than the maximum load. And the idea of this calculation is that you want to use only one calculation. So you have your maximum stress level should be based on the same load cases as the one for fatigue. So how do they take that into account? They also have another classification, and that is on the on the load spectrum. Yeah. So if I have always the maximum load, then this classification is 1. It's always then I have the load spectrum factor is then the maximum, so that's 3, and the P1, so that's basically the average weight is the maximum weight. Then you have P0. For example, if I have a construction crane, I use the construction crane for all kinds of stuff, and I rarely use that for my maximum load. And then these things in between, of course. So if you have a container crane, depending a bit on where your average is, here is the average crane, the average load is around 1/3 of the maximum, and here it's around 2/3 of the maximum. So in this classification, we take into account the number of load cycles and the load spectrum. So how often do I take a lift with the maximum load? And then that comes into a matrix. So the usage class is here, and the design spectrum is in this case, and then you come up with a crane class. And that crane class we can then use for allowable stresses. So here you have your crane group or crane class, and then you have a stress variation or a maximum allowable stress, which depends on the crane class, the material type, this one and that one. So you can see that 180 and 270. So if I have a higher material group, I can allow a bigger fatigue stress or stress variation, but only if the number of load cycles is not too much. Yeah, because if I go down, I see in the end at crane group 6, I have here 120 and here 132. So there is a difference for the non-welded part, but that is not that big, and that is only in the case where you have W0, so there's no stress concentration in the plates. So for W2, these values are already the same. So if you get stress concentrations, then the effect of better quality of material is already gone. And if you use your crane, if the usage class is increases, so from here till there, then the allowable fatigue reduces. Same for welds. They start with the same categories. If I are at the heaviest used class, these values are the same. But if my reduction in number of cycles becomes bigger, you basically have a higher limit because your steel it inflicts also with the yield limit. Yeah. So the idea, although it is different, the idea of classifications and so on is still the same. And for lifting appliances, this method is still used. You set up a classification based on the number of cycles where you use your lifting appliance or your crane for, and in this way you quickly get an idea of the fatigue damage and the fatigue limits. Be aware that these crane crosses, they do not take the delta stress from plus to minus, but they take 2 times the allowable stresses. And I'll explain you why that is. What do I have this curve? Yeah, here. So they take into account also some kind of a kappa value. So they want, since they want to use only one limit, they want to calculate the maximum stress and the minimum stress over a lot of load cases for every point. And they take these two values, and based on that, they see, okay, is it a varying stress or not? And does it change sign or not? So here, depending on the type, you have a different kappa value. A kappa value of -1, that means that the minimum stress and the maximum stress are the same. Then my limit, the idea of the limit, and that is why you use only delta sigma. Then if I am in the case where the maximum stress is the minimum stress, so that is here, then this is my limit in allowable stress. So that is the reason why crane standards use the stress amplitude and not the stress variation. Okay, we go back. Yeah, so the delta sigma can be twice the allowable stress. Just if you want to compare these categories with other methods, there it becomes important. Yeah, so if we look at this curve a bit more in detail, and here it's in English, luckily, so you could better understand it. Here we have the utilization class with the numbers, and here we have the load spectrum. You can transfer one in the other, and you can say, look, if I have a fully loaded crane, then I have the category 4, 5, and 6. So that gives me 2 million load cycles. That is this one. That is crane category 6. 5 is 630. 4 is 200, and then you can go in the cycles. Yeah. So if we have that, then we can use these original classes, and then we can construct our Palmgren-Miner formula, and then you see that these classifications, these points, if we go higher up, they follow exactly a straight line, and the only limit is here because that is the yield limit. Yeah. So although this looks like a classification and Palmgren-Miner seems to be gone, in the end it's based on exactly the same method. Yeah, so lifting appliances do have the same idea behind it, but it is in order to make the calculation process easier, the number crunching and it becomes harder, and the Palmgren-Miner graph is hidden. If you open that standard, the Palmgren-Miner rule with these classifications is not shown, although it is there.